Let's look at an example involving uninhibited population growth. A corporation is selling franchises for pizza shops throughout the country. The marketing manager estimates that the number of franchises N will increase at the rate of 10% per year. That is, the derivative of N with respect to T is equal to 0.1 times N. So here we're representing the 10% as a decimal, 0.1, times the function N. Now we've learned that the exponential function is the only function for which the derivative is a constant times the function itself. So we know when we're coming up with a function to represent N, it has to be an exponential function. And from our notes, kind of the general way we represent uninhibited population growth is to use the equation P sub t equal to P sub 0 e to the kt, where P sub 0 is the initial population and k is the growth rate. So we're trying to set up an equation that looks like this. So for part A, we want to find the function that satisfies this equation, and we're going to assume that the number of franchises at time t equals 0 is 50. Now in this specific example, we're using N instead of P. So we can come up with an equation that looks like N sub t equal to N sub 0, where N sub 0 is going to be our initial population, times e to the kt. T is our variable, t is time, so we need to figure out what our initial population N sub 0 is and what our growth rate k is. Well, we're told to assume that the number of franchises at time t equals 0 is 50. So our initial population at time t equals 0 is 50. So N sub 0 is 50. We're also told that the number of franchises will increase at a rate of 10% per year. So that is our growth rate. So our k then is 10%, which we want to write as a decimal, so it is 0.1. So we can substitute those in and we have our equation. So we have N sub t equal to 50 e, and replace k with 0.1 t. So there is our function that satisfies this equation. For part B, we want to find how many franchises will there be in 20 years. So at time t equal 20. So we want to plug 20 in for t. So N sub 20 is equal to 50 e to the 0.1 times 20. And we can plug that into our calculator. So we have e to the 0.1 times 20. 0.1 times 20 is 2. So we have e to the second power. So this is 50 times e to the second power. And then e to the second power, if we round that to, say, 3 decimal places, is 7.389. So then multiplying that by 50, and we get approximately 369, rounded to the nearest whole number. So how many franchises will there be in 20 years? There will be 369. For part C, in what period of time will the initial number of 50 franchises double? So here we want to know when it'll double, so we're wanting to know the doubling time. Well, from our notes, we found that t, the doubling time, is equal to the natural log of 2 divided by k. That is our formula for finding doubling time, where k is our growth rate. So here we have the natural log of 2 divided by k, which is 0.1. And if we calculate that, natural log of 2 divided by 0.1 comes out to be approximately 6.9 years, rounded to 1 decimal place. So we can expect that the initial number of 50 franchises will double in approximately 6.9 years.